Here we go, we have a question, longest consecutive subsequence. So you have given an array of non-negative integers. We need to find the length of the longest subsequence such that the element in the subsequence are consecutive and the consecutive elements can be in any order. So you have given this array, and in this, let's start the sequence from 1. 1 is there, 2 is there, 3, 4 is there, 5 is there, 6 is there. So one subsequence length is 6, and we can start another subsequence from 2, 3, 4, 5 or 6, but that subsequence is of less length. Then another subsequence we can start it from 9. So so another sequence we have from 9 onwards. So this subsequence length is 1 only. So the longest is of length 6. Then we got this example. We got 1, 2, 3, 4. So this is one subsequence. Its length is 4. Another subsequence we have starting from 9. So 9, 10. We got 2 length. Then this third subsequence starts from 20, and we got length only 1. In this question, we can start from 9, 10, 11. So only 11. 11, yeah, 12 is there, 13, 14, 15. So longest length is 7. So now let's try to build the approach. So first of all, the array is in unsorted order. So first approach can be to first sort the array. So after sorting, we got like this: 5, 6 is there, so till 6. Then other subsequence we have from 11, 10, 11 there, then 12 there, 13, then 14 is not there, so till only 13. Then we got 16. So you can start from index 1 and check if previous length, previous element is less than 1. If that's correct, we got a subsequence, and till here we got length as 6. Then we got this element, previous element is not -1, not equal to current element -1. So we need to start, we need to take this position as my starting point and start and move forward. So this is one of the approach, and in this the time complexity will be n log n, but we can optimize it. We just need to find the starting point. So and after that we just need to check whether that particular element is present or not, and its increment, and after that we will increment it and check if that particular element is present or not. Then we will increment and check whether that particular element is present or not. So um, this can be solved using set. So we will add each and every element in the set. So set contains this element. So this is our set. Now we need to check, can this be a starting point? How do we check whether this is a starting point or not? So starting point is considered when we subtract 1 from the current value and that value is not present in our set. So we got 5. If we subtract 1 from it, we got 4, but 4 is there. So 5 is not a starting point. Then we got 6. If I subtract 1 from it, we got 5, but 5 is already there, means 6 is also not a starting point. Then we got 10. So if I subtract 1 from it, we got 9, but 9 is not there. So means a subsequence can be start from 10. So just iterate till we got our number. So we got 10. So 10 is there. Current subsequence length is 1. Then we will increment 11. 11 is there. Yes, 11 is there. Subsequence length will be 2. Then we will again increment. We got 12. Yes, 12 is there. So subsequence length again increment. Is 13 present? Yes. So again increment. Then we got 14. 14 is there? No, 14 is not there. So we got only 4. So now let's store this. This can be our answer. Answer can be 4. Now let's move ahead. We got 13. Next value is 13. Can 13 be a starting point? No, because 12 is already there, means 13 is somewhere middle in a subsequence, but 13 is not a starting point. Can 16 be a starting point? If I subtract 1 from it, and that number should not present in our set. So we got 15, 15 is not there, so 16 can be a starting point. So we got current length as 1, then we have to increment it. We got 17, 17 is not there. So this subsequence length is 1, but we already contains greater value, so will not update our answer. Then we got 4. Can 4 be a starting point? No, 3 is already there. Can 1 be a starting point? Yes. So we have a current value is 1, because we got a value as 1. Then we increment our value. We got 2. Yes, 2 is present, increment. Then we got 3. 3 is present, increment. Then we got 4. 4 is present, increment. Then we got 5. 5 is there, increment. Then we got 6. 6 is present, increment. Then we got 7, but 7 is not there. Subsequence length is 6. So this is the greater value. Just update the answer and move ahead. So we have traversed till 1. Can 12 be a starting point? No, 11 is already there. 3 be a starting point? 2 is already there. 2 be a starting point? No, 1 is already there. Can 11 be a starting point? No, 10 is already there. So the maximum we can have is 6. So in this case, the time complexity will be order of n, because we have to iterate in each and every value. And suppose we go to starting point, then only we will move forward till n times in the worst case. And space complexity is order of n or order of unique values. In the worst case, if every element is unique, then we got order of n. Now let's code this. Code is very simple. So we got a set. Next, we have to add all the elements. We got answer. Then we have to iterate in the set. Then just check. If I subtract 1 from it, then we don't get value. It means ith value is the starting point. So starting point is the ith value, and initially current is 0. If this value is present, just increment your counter and start. We need to also increment start value, because we need to find next value. At the end, we just need to check whichever is greater between count and answer. Let's submit this, and the code is given in the description box. We have already discussed about the time and space complexity. I hope you have learned something new. Give this video a thumbs up and subscribe to this channel. Thank you all for watching.